Good evening, guys. All right, so I'm here to explain the problems that you had, or the questions that you asked on the midterm study guide. All right, so I had a request for 4, 11, 13, 15, 19, and 21. I'm going to start with number 4. So it said to complete the identity. They gave me sine over cosine plus cosine over sine, and this was a multiple choice, so whatever I got needed to match one of the answers. I know you would think that sine over cosine is tangent, and cosine over sine is cotangent. However, that wasn't one of the options. So what we should do here is make the denominators the same, okay? Because I cannot add my fractions unless they have the same denominator, which means that this side would need a sine, all right, in the denominator and the numerator, and this side would need the cosine. All right, now they both have the same denominator, which is sine cosine. Sine theta times cosine theta. All right, in the numerator, I now have a sine times sine, which is sine squared of theta. Then I have the cosine times cosine after the plus. Cosine times cosine is cosine squared theta. Okay, so from here, hopefully you recognize that this sine squared plus cosine squared, which is the same thing as cosine squared plus sine squared, is one of our Pythagorean identities. It's the main one. It is the parent one. And we know that sine squared plus cosine squared equals 1. So the numerator is the number 1. And the denominator, I still have my sine times cosine. All right, this is still not an option. So what they did is they split it up. They said this is equivalent to a 1 over sine times a 1 over cosine. Theta, theta. All right? Right, because 1 times 1 is 1, and the sine times cosine will give me the sine cosine that I had in the denominator. These are equivalent. And from here, I should recognize that 1 over sine is equal to cosecant. And 1 over cosine is equal to secant. I remember that the S goes with the C, and the C goes with the S. So cosecant theta, secant theta. I think it's the other way around on our review. They have the secant theta first, but same thing, right? Because multiplication is commutative. So that's how we do number 4. All right, number 15. I'm skipping 11 because that's going to take my entire board. I will come back to that. But number 13, by the way, if you guys are looking at your review, the answer to 13 was it is not an identity. It doesn't matter what you do to it. You cannot make one side equal the other. It just can't be done. So if it cannot be done, then the answer is it is not an identity. So on to 15. Find cosine 2 theta, given that the sine of theta is 20 over 29 and theta is in quadrant 1. Okay. So cosine 2 theta. 2 theta means I need to use one of the double angle identities. I put that up on the board down there. All right, so 15 has 3 different options. Cosine of 2x theta has 3 different options. Since what they gave me was sine, then I want to use the option that just has sine in it. So that would be the third one down. All right, I want to use the one that says that cosine, it says 2x on the board, but 2 thetas, whatever argument you want to use, is equal to the 1 minus 2 sine squared theta. Okay? Okay, so this is the general formula. So cosine of 2 theta should be equal to 1 minus 2 times, I know what sine is. Sine is 20 over 29. So I'll just replace the word sine with the number 20 over 29. That is what sine of theta is. Sine of theta is 20 over 29. And then I just need to remember to square it. And then I just plug it in my calculator. And when I do so, what does this give me? Okay. 15, when I do this, it gives me 41, right? 41 over 841. No, I do not expect you to do that in your head, did I? No. All right, now there were choices on here on your midterm review. You have a 40 over 841. You also have a negative 41 over 841. I said that wrong. All right, so the way I determine whether this is positive or negative is that last part of the sentence where they said that it's in quadrant 1. You remember quadrant 1 is this one, and everything is positive. Remember your first coordinate is your cosine, and the second one is your sine. Your x is your cosine, your y is your sine. So since I'm in quadrant 1, everything is supposed to be positive. I was finding cosine, so cosine is supposed to be positive. So that is my correct answer. I do not change the sign. The only way I would change the sign, you remember all the parts. This is negative, positive. So if it were in quadrant 2, my cosine would be negative, or if I were in quadrant 3. If I were in quadrant 3, my cosine would also be negative. But I'm not. I'm in quadrant 1, so I'm good to go.